Now we're going to talk about an ellipse that is not centered at the origin, but centered at some other point, hk. And we use hk to represent the center. So this point right here, oops, point in the middle, that's going to be hk. So you got to remember that. All right. We still want to know the coordinates for the vertices, though. And the coordinates for the vertices, you have to picture, well, I've moved that h units, to the right. It could be to the left, but h units, okay? And so when we're thinking about the vertices and their coordinates, it's going to be like this. And this is for the kind that are elongated. So this is this kind. X squared over a squared plus y squared over b squared equals 1. No, I don't want to write that. Dang it. That's if it were centered at the origin, but we're going to center it at hk. So x minus h squared over a squared plus y minus k squared over b squared. That would be equals 1. That would be the standard form then for an ellipse that's elongated in the x-axis direction, a pancake shape, and then is centered at hk. All right, now let's go back to the vertices then. So what we have to do is we have to take h and add a to it, comma, k. So that's going to be the coordinates for that vertex there. And then on the other side, it's going to be h minus, no, it's not a very good minus sign. Let me try again. H minus a, comma, k. All right, so that would give you the coordinates then for the vertices. Now the co-vertices, so the point up here and the point down here, those are going to be h, comma, and then you're going to have to do the same thing with the k. So it's going to be k plus b, and then down here it's going to be h, comma, k minus b. All right. And then we also have the coordinates for the foci. So it's along the major axis here. And so say your focus is there. Then the coordinate, or one of them anyway, let's do this one over here as well. And so it's going to be h plus c, comma, k. And then the other one's going to be h minus c, comma, k. And you might want to spend some time thinking about these coordinates and why they're doing that. It's a lot of stuff to memorize, to try to just memorize the whole thing. You can get a page of notes and follow those along. Sometimes that's not always easy to do, though, if you don't have a page of notes handy, or sometimes it's just hard to follow the formulas. But you can think through it a little bit, and as we go through an example, we'll see some of that as well. Okay, now let's do the other kind, where it's going to be this standard form, x minus h. H always goes with x, and the k always goes with y. That doesn't change. And it equals 1. Squeeze it in there. Okay, but now see, our vertices are going to be, what did I do them in blue before? Our vertices are going to be up here and down here. And so this vertex up here is going to be h, comma, and then we're going to say k plus a. And then this one down here is going to be h, comma, k minus a. It's a little bit easier to graph than to come up with these formulas, actually. Okay, so now we have our center here. Our major axis is going this way. Okay, and so let's talk about the co-vertices. So there's one over here. the one over here. They should be in line with the center there. And those co-vertices are going to be H minus B, comma, K. And then this one's going to be H plus B, comma, K. And all this information is in the textbook, which you can download for free. It's OpenStax pre-calculus. Okay. And we got to do the vertices, so I haven't done those yet. Okay. Or the foci. So focus here, just kind of drawing them in. So this one up here is going to be, the H is going to stay the same because it's in line with the center. It's just going up and down. So it's going to be K plus C. And then this one down here is going to be H, comma, K minus C. And that should be all those formulas. Like I said, it's a big chart. You get a picture and line everything up. Again, A is greater than B. We still have that. A is greater than B. And still, C squared is equal to A squared minus B squared. So those two things still stay true from the beginning. Okay, let's look at an example then. So what's the standard form equation of the ellipse that has vertices -2, -8? So again, I'm going to draw this out because it's going to be easier for me to see that way. So -2, -8, way down here, and -2, 2. Okay, and then it tells me the foci. I'll do those in green. -2, 7. I'm sorry, -2, -7. And then -2, 1, right there. Okay, now I know then because of the foci and the vertices that it's that elongated shape. It's like this, the egg shape, the ellipse. And I know some other things by drawing this. I know the distance between here and here. So that's a distance of 10. You could just count that out, or you could subtract that out and find the difference. But that difference is 10. And so I know the center has to be halfway in the middle. So it's going to be down, let's see, 1, 2, 3, 4, 5. I know that has to be the center right there. So I just do that by getting the graph and looking at that distance and figuring out what halfway is between that. And you can do that mathematically. You're thinking, well, those numbers worked out nicely. But you could do that even if they didn't work out nicely. Hopefully they will. But now we know the center of the circle, or the ellipse. The center is at -2, comma, -3. And that's going to be our H then, and our K. So we've got that part figured out, so that's nice. And here's the form that we're going to try to follow. We're going to be trying to follow x minus h squared over b squared, because it's the egg shape, plus y minus k squared over a squared, and that equals 1. So we know h and k because we just figured out what the center was. Now, do we know what a is? Do we know the distance from the center to a vertex? Yeah, we know a is 5. We don't know what b is, but we do know what c is. C is the distance from the center, so it's this distance here is the C. And so that's going to be, you can just count it out, 1, 2, 3, 4, so C is 4. Now we can use that formula, C squared equals A squared minus B squared, to figure out B. So we've got what? 4 squared equals 5 squared minus B squared, so that's 16 and 25. I think this is a nice one. I think I have the nice one. Probably the one on the homework's trickier. Don't always plan that, but I know B is 3 now. I could draw that if I really wanted to. I could say, well, my co-vertices then are going to be 3 units from the origin. 1, 2, 3, so I know one of them's there. 1, 2, 3, I know one of them's there. And now I can actually draw the ellipse. The ellipse is going to go through the vertices and the co-vertices. It's going to look better than that if I could draw an ellipse, but that's how it is. And I have enough information to get the standard form. They didn't ask us to graph it. I just think it's helpful to graph it sometimes, and it's a little bit of practice too. So, but we know a squared, we know b squared, we know c squared. Or, well, we do, but we just need the a, b, h, and k. Okay, so here it comes, x. Now it's going to be minus h, and h is -2, so that's going to make it +2. And then my b squared was 9. And then it's going to be y minus k, but k was -3, so it's going to be y plus 3 squared. Don't forget the square on that standard form. And then a squared, well, a was 5, so a squared is 25 equals 1. And that's how you would do a problem like that.